Good day everyone, I am Rienna Estrella and our topic is lateral earth pressure. Pressure is the horizontal pressure imposed by soil on retaining structure such as retaining wall or basement wall. So lateral earth pressure is a sideway push that the soil applies. Importante siya since it impacts how the soil settles and how strong it is. So the pressures is important in designing structures like retaining walls, basements, tunnels, and foundations, since it will help us predict how soil move and how soil behave. So when we build things like I've mentioned, like the tunnels, retaining walls, i-consider din na to ang lateral earth pressure since it helps us ensures the structures will stay strong and stable over the time na to prevent the issue like collapse sa atong building. So historical background, the study of earth pressure dates back to 18th century pa. Engineers such Charles Augustin de Coulomb and Henry Rankine made a notable contributions. Coulomb, he was among the first to contribute the significance to the earth lateral pressure. He looked at how solid block of soil might slide along a surface. So, and which introduced to us the concept of passive and active earth pressure. Then, Henry Rankine came. He took things further by solving the problem of soil pressure for a whole mass of a soil on the verge of failure. Not just like pareha kay Coulomb, nagikuha lang na part. So, initially, Rankine's theory only applied to soils without cohesions. And that's all my part. And the two theory and Rankine's theory will be discussed to another two next reporters.
Okay, so good day everyone. My name is John Russell H. Floreto here in front of you to discuss types of lateral earth pressure. So to go to the types of lateral earth pressure, we must understand first the general concept of what is lateral earth pressure. So lateral earth pressure is the horizontal pressure imposed by soil on a retaining structure such as a retaining wall or a basement wall. And this pressure is usually caused by a force which is created by the weight of the soil and any additional external loads na nag-act sa wall. So, makita nato sa figure no, nga natay wall with a height of h and subjected siya sa load P. So, tungod ng load P, makabuhat ta og pressure nga ma-impose sa ato ang wall kay concept naman na sa forces no nga kuan sa from mechanics nga kintahay na atay load niya maano nato ang isa ka section kay makabuhat jud og stress or pressure ana nga section. So ang mabuhat nga pressure anang load P is kanang lateral earth pressure or denoted by sigma H. So, understanding lateral earth pressure is critical in geotechnical engineering and structural design, especially in structures that include soil or other granular materials. Continuing with the discussion is we will go now to the types of lateral earth pressure, and when we say lateral types of lateral earth pressure, we have three types which are at rest, active, and passive. To differentiate the three no is we will have an analysis. So suppose na tayo wall frictionless wall AB which is kana siya frictionless wall AB. Tapos naa siya gi-retain na soil mass. Ang soil mass kay kanang naa sa iyahang right kana 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 kana. Suppose magkuha ta og soil element kani soil element kana soil element. Ang kana nga soil element at a depth of z kay subjected na siya sa vertical o horizontal effective pressures which are denoted by sigma prime h and sigma prime o respectively. Ngano man na? Kay kung imong tan-awon ang kana nga soil element kinasya sa ilalom and tungod sa weight of sa soil ug sa anything nga naga-act sa beneath that is gina gina-impose sa forces or kadto nga external loads ang kanang types of pressure nga na subject ana nga soil element. So sa concept sa ano no sa lateral earth pressure natay tinatawag nga K or earth pressure coefficient which is the ratio of the horizontal effective pressure and the vertical effective pressure. And kanang K is importante kay na siya sa pag-determine sa lateral earth pressure in all types whether at rest, active or passive. So gikan ato na ano na analysis kay naay tulo ka cases na ma-form. And going to the first case is case 1. If wall AB remains static as it does in the figure, where no lateral movements occur either to the left or to the right of its initial position, the soil mass will be in a state of static equilibrium. So, ang gimina na statement is ano no, understandable kayo. Okay? If ang kanina wall, kana nga wall, is walay movement ka mahitabo no, dili siya mo anha diha or dili siya mo anha diha, ang kaning soil nga gi-retain niya, ang kanang soil nga gi-retain niya kay mo reach og static equilibrium or magkuan po siya na stationary lang, mag-act as stationary lang. So, sa kaning case is from the relation of the earth pressure coefficient and stresses involved kay makabuhat ta og another relation where K is equal to K O is equal to sigma prime H over sigma prime O, where sigma prime O is referred to sigma prime H rather is referred to as the at rest lateral earth pressure and KO is the at rest earth pressure coefficient. So gilisdan lang tong ano gaida tong relation na K is equal to sigma prime H over sigma prime O to sigma prime H or as is dahil siya no as is stationary man walay nahitabo so mao na original position niya na. So going to case 2, if the frictionless wall AB tilts about its bottom to a position of A prime B as shown in the figure, then a triangular soil mass ABC prime will reach a state of plastic equilibrium and fail sliding down the plane BC prime. So ang kanang gimin ana na statement no is if ang wall AB kana wall AB kay mo tilt about its bottom diri gikan diri nya mo move siya mo tilt padulong ana kana so ni move nanay movement na hitabo no padulong sa iyahang left. So ang katong gi-retain niya nga mass of soil kanino kana kay makaporma siya og triangular mass kay tungod ani nga movement no naay mahimo nga failure envelope. And diha nga failure envelope which is mao na siya ang plane BC prime ang katong nasa iyang babaw nga ano nga soil kay mag-fail pa slide down pababa kay maano lang makita na to sa figure no nga wala na mo retain diri dapita. So ang katong mga soil mo ana diha hangtod moabot diri kay ang movement kay downward man no downward. So gikan sa relation na pud gaina no na K ug sa stresses involved makahimo na pud tag bag-ong equation nga K is equal to Ka is equal to sigma prime H over sigma prime O is equal to sigma prime A over sigma prime O. Ang H no kay gilisdan lang nato og A where sigma prime A is referred to as the active lateral earth pressure and Ka is the active earth pressure coefficient where A obviously ginaano niya na active na siya. Going to case 3 no, if the frictionless wall AB tilts about its bottom to opposition of A double prime B as shown in the third figure, then a triangular soil mass ABC double prime will reach a state of plastic equilibrium and will fail sliding upward along the plane BC double prime. The relation of the earth pressure coefficient will then be no, pareha lang gaina no, makita nato nga ang wall AB wall AB sorry sa drawing, sorry sa linya na iwi kay naay movement na itabo pero karon sa case 3 is pasulod na siya sa soil pa-right na muna ng movement niya no kana kana na ang wall karon so tungod na ang movement nanapod tayo mahimo ang failure envelope which is ang ano plane BC double prime and ang soil mass nga na-retain kani nga soil mass trying kana gikan diri kay mo-slide ni siya pababaw kay mura siya na squeeze pababaw iyang movement no iyang failure kay mura siya na squeeze tungod sa movement ana nga pasulod sa soil. So bag-ong relation kay gikan gyapon atong inang relation sa K ug sa stresses involved kay ilisdan lang ang kuan ang subscript na H into P where ang P mo na siya nagpasabot nga passive ang kana nga ang involved ana nga relation. So mo na siya no where stress prime P is the passive lateral earth pressure and Kp is the passive earth pressure coefficient. Aron simple lang na pag determine sa difference sa tulo ka type sa lateral earth pressure kay kung ano lang nimo ang ilahang movements. If ang movement kay wala, no movement at all, stationary ang wall or ang retaining structure man is mo na siya at rest na siya nga at rest ang lateral earth pressure nga na-impose sa retaining structure ana. If ang wall kay ni move away from the soil kay ang kuan na ang type of earth pressure kay active and opposite of that if ang wall or ang retaining structure kay ni move pasulod sa soil towards sa soil kay muna siya ang passive lateral earth pressure. Discussing further, we will now go and discuss deeper the addressed lateral earth pressure. So in addressed lateral earth pressure, we have two that I will be able to cover in this discussion, which is the lateral earth pressure at rest for dry soil and the other one is lateral earth pressure at partially submerged soil. So going sa first is for dry soil. So kung ano po the figure, kita na po nato nga natay wall AB, same analysis kay na with a height of H and mag-ano tag soil element at a depth of Z. Soil element no kani, soil element. So, kita man nato nga Z, kana Z. So the figure shows a static wall AB. So static mo na siya ang nag muna siya ang definite na statement para matawag na tong at rest ang wall. So kaning nga wall is nag-retain siya og mass, soil mass na kanang uga with a unit weight of gamma. So at a vertical depth of Z, ang vertical effective stress or ang sigma prime O kay equal na siya sa unit weight sa soil, sa dry soil, ug sa depth, sa certain depth, ana nga point. So, di ba sa ato ang ano gaina, sa ato ang relation nga K is equal to kana, if kani kay equal og gamma z, so makuha na to ang horizontal effective stress na kani, if ano nato no, i-isolate nato ning kani, isolate nato ang sigma prime h. So makahimo tag equation na sigma prime h is equal to ko unit gamma z, or mo na siya ang formula sa lateral earth pressure for dry soil and in an at rest state. So for the determination of k na siya dira no, k at rest earth pressure coefficient. So natay duha ka pamaagi for normally consolidated soils and for over consolidated soils. So first, normally consolidated soils. So the earth pressure coefficient or KO is equal to 1 minus sine phi theta, sine phi prime rather, where phi prime is the angle of internal friction. And going to the other one, the over consolidated soils, is earth pressure coefficient or KO is equal to 1 minus sine V prime times OCR raised to sine V prime, where V prime is the same as the first one, angle of internal friction, and OCR is equal to over consolidation ratio. So mo ni siya ang so mo ni akong gi-take consider na ratio for soils na overstrengthen, no? And kanang OCR is equal to preconsolidation ratio or sigma prime C over effective overburden, or mo na siya ang effective vertical pressure na kuan sigma prime O. Ang kaning preconsolidation ratio or sigma prime C is mo ni siya ang max na effective vertical pressure na experience sa kuan sa soil before sa present time. So maximum, no, mo na itong tanawon. Pero sa problems usually kay ang OCR kay given, pero if dili man siya given kay ginahatag ang preconsolidation ratio na sigma prime C. Continuing further, no, is we will now establish the equation for calculating total force per unit length. So sa figure na gipakita kay ano, ano siya ang pressure diagram or variation sa pressure with respect sa iyang depth, no? So depth, if ano, increasing ang depth, if ang z is equal to h, ang pressure nga ma-establish, no, kay mo na ni siya diri kana, which is equal to ko gamma h, the ano no, the formula for the horizontal effective pressure or lateral earth pressure for dry soil. So para makuha na to ang total force per unit length, kuhaon lang nato ang area sa pressure diagram. So, kuhaon lang nato ang area ani, kani siya nga diagram, naka-diagram na. And unsa man siya nga figure, sa figure nga na form, diba triangle? And from the area of triangle, base times height, 1/2 base times height, maka-establish ta mga values sa kani nga triangle sa iyang respective base ug height. Unsa man iyang base? Ang iyang base is ang lateral earth pressure nga nag-act sa wall, which is ang KO gamma H. So kung i-substitute nimo, KO gamma H. Unya ang iyang height kay ang distance gikan sa surface padung kung asa tong pressure of interest. So at this point, no, ang iyang height is H. Simplifying, makuha nimo ni nga formula, which is PO, the ang nag-denote sa total force per unit length is equal to 1/2 KO gamma H squared. Ang ganing gamma, no, kay dapat siya sa unit weight siya sa soil na uga, kay ang ganing pag-calculate sa total force per unit length is for dry soils only. So na-establish na nato ni ang total force per unit length. So continue ta sa next discussion. So going with the second condition, no, the lateral earth pressure at rest or partially submerged soil. So sa kaning part kay nanay na ang soil kay nilapas na sa groundwater table, which means saturated na ang soil. Sa kanina part, kana lang na part padulong dira where ang Z is pa lang siya, less than or equal to H1. Makita nato na babaw pa ang soil nga gi-retain sa groundwater table, which means ang soil nga na-retain diri sa babaw kana dira going upwards is dry. So ang iyang equal, so ang pressure nga ma-enact gikan sa gikan sa surface padung diri is for dry soil lang. So ang earth pressure would be equal to KO gamma H1, which is ang H1 mo ni siya ang height kung asa taman ang dry soil nga na-retain. However, if ang Z would be greater than or equal to H1, then ang total pressure or total lateral earth pressure nga impose sa ato ang wall kay mao siya ang sum sa earth pressure nga nag-act sa wall ug sa pore water pressure, which is denoted by U. So beginning with the earth pressure, ato sang establish ang earth pressure, no, kanilang sa nga part, diri lang sa nga part. So ang effective vertical pressure sa dira nga part is sigma prime O is equal to gamma H1, where kani nga kana is dry unit weight sa soil. Kanya H1 maklaro na sa figure plus ang gamma prime times Z minus H1, where ang kani siya ang distance gikan sa groundwater table to the point of interest under the said table. And ang kani mo ni siya ang effective unit weight of soil. Diri na siya magamit properties of soil from chapter 1, where makuha na siya gamit ang i-minus ang unit weight of water sa unit weight na saturated. Hence ang lateral earth pressure kung i-substitute ang sigma prime O na bag-o sa kana nga formula, mahimo siyang ingana. So ang earth pressure nga establish sa soil under the groundwater table would be sigma prime H is equal to Ko times gamma H1 plus gamma prime times Z minus H1. So, ano no, going with the discussion sa another parameter para makuha ang total lateral earth pressure if partially submerged ang soil is ang pore water pressure, which is denoted by U, and U is equal to the unit weight of water times the distance from the groundwater table to the point of interest under the said table, where it is denoted by Z minus H1. Ang iyang variation with depth or iyang pressure diagram kay gi-show sa triangle IJK sa previous figure. Hence, ang total lateral pressure is represented by the equation sigma H is equal to sigma prime H plus U, where if i-substitute nimo ang values, so for sigma prime H, Ko times gamma H1 plus gamma prime times Z minus H1. And for U, unit weight of water times Z minus H1. Same sa sa pag-calculate sa total force per unit length sa dry soil, same ra pud siya sa pagkuha diri nga condition partially submerged soil. Ang total force per unit length kay kuhaon lang ang area sa pressure diagrams. However, sa diri na case kay daghan na og figures ang i-consider na areas. To understand further the discussion, no, we have an example here. The figure shows a 15 feet high retaining wall. So wall, 15 feet. And the wall is restrained from yielding. So, ang kanina wall is dili siya mo-move. So, meaning at rest. Calculate the lateral force PO per unit length of the wall. So, also determine the location of the resultant force. So, assume that for sand, OCR is equal to 2. Ang kanina statement kay mo na siya nag-signify na ang soil nga gi-retain sa retaining structure present kay over-consolidated. So atong given no kay ang ato ang angle of internal friction is 30 degrees, ang atong dry unit weight sa soil is 100 pound per feet cube, and ang ato ang unit weight saturated is 122.4 pound per feet cube. So first no, atong kuhaon is ang KO. KO. Kay importante kini siya sa kay kung wala ni dili nato makuha ang lateral earth pressure. So for over-consolidated soil no is if nakahinumdum mo 1 minus sine V prime times OCR raised to sine V prime. Ato ang V prime is 30 and atong OCR 2. So i-substitute lang ning duha no sa formula makuha na to ang 0.707 na KO. So establish na to ang mga pressures present at each significant depth. So at Z is equal to 0, ang pressures present kay 0 pod kay at the surface pa man na. And ano siya sa atmospheric pressure? 0 siya. At Z is equal to 10 feet. Magamit na to ang katong sa for dry soil pa lang kay at 10 feet 10 feet and below kay wala pa siya na sa groundwater table, meaning dry pa ang unit weight sa soil or dry pa ang soil nga gi-retain sa structure. So from the formula para sa vertical effective pressure, mo ni siya ang Z, mo ni siya ang dry unit weight. So makakuha tag pound 1,000 pound per feet squared. So substituting 1,000 to the formula for lateral earth pressure for dry soil, makakuha tag 707 pound per square feet. Ang pore water pressure at this point is 0 kay yun na nga wala pang tubig sa above sa groundwater table. So going deeper no at Z is equal to 15, ang Ato ang vertical effective pressure is malahi na kay lagi 15 feet ang soil nga na-retain sa structure is submerged na siya sa groundwater table, meaning na siya presence of water, meaning saturated na siya. So gikan sa formula no, mo ni siya ang Z, mo ni siya ang dry unit weight plus mo ni siya ang katong distance gikan sa groundwater table below sa said table at the point of interest, and mo ni siya ang effective unit weight sa soil or katong gamma prime. So isolve nato na siya, makuha nato ang 1,300 pound per square feet. So i-substitute nato na siya sa formula sa earth pressure no, where it is KO times vertical effective pressure, makakatag 919.1 pound per feet squared. So for pore water pressure no, ang kon di ba kay unit weight of water og ang katong distance gikan sa groundwater table padulong sa point of interest below it. So mo na siya 5 tapos unit weight sa water for English units kay pound per feet man ang given. So 62.4 ang gamiton, makakuha tag 312 pound per square feet. So pag human mo diri no, kay mo proceed ka og kuan nila og himog diagram. So nana tayo mao ni mo siyang diagram. And as I've said earlier, ang pagkuha sa total force per unit length kay kuhaan lang nimo ang total areas sa kaning diagrams. So mo ni siya area 1, area 2, area 3, and area 4. So for area 1, triangle man ang 4. So 1/2 times 10, 10, 10, times ang iyahang 707 na pressure, which is mao ni siya kani. So natay makuha nga 3535. Next is for area 2. Kuha natin 5 no. Kay square man siya, so length times width lang. So width na 5 tapos length na iyahang 707 kay from this point to this point is 707 man. So makuha ang 3535 pod. So sa area 3 is triangle naman pod. 1/2 times 5 pod, 5 times ang iyahang base na 919.1 minus 707. So mahimo siyang 212.1. Natin makuha nga 30.3. Lastly, ang area 4, same ra siya sa area 3, triangle. So 5 ni, 5 ug ang iyang base na 312. So natin makuha nga 780. So ang atong answer, total force per unit length is 8,380.3 pound per feet. So for the other part of the the problem is kuhaan po nato atong resultant. So for location resultant, kung ato ang himuong reference point ang bottom sa wall kay mahimo nga ani ang formula. Asa nagikan? Gikan na siya sa Varignons. If pa mo familiar mo, di ba Varignons is area total times x bar is equal to summation of individual areas times individual distances from the centroid to the point of reference. So if nimo na, if isolate nimo ang x bar, which is ang ato ang kailangan, mahimo siyang ingana. So sa kaning formula no, kung nimo dira, i-associate ang z bar mo ni siya ang x bar. Kanya summation of moment of pressure diagram about C, so mo ni siya. Kay ang kaning distance from centroid to the point of reference is same lang na siya sa moment arm. So, pwede lang matawag yapon ni siya as a whole na as moment. And ang area total is katong total force per unit length. So, para maano na to no, atong drawingan ubalik ang katong kuan diagram ana 10 ni dire, 5 ni dire, tapos 1, 2, 3, 4. So, for area 1, no, mo ni siya ang ano, di ba, area 1, 3535, nakuha na to ay nasa pagkuha sa total force per unit length. Kani. Para makuha na to yung moment arm kay from the bottom of the wall, himo na tong reference point ang bottom of the wall. Kani. Gikan dira, padulong dira is 5 na mandaan. Tapos, ang force nga magkuan, if ano nimo kanilang na area, di ba sa centroid man siya mag-act. And kanina nga distance is 1/3 sa 10. So, mo ni ang moment arm sa area 1 is 5 plus 10 over 3. Kay ang centroid sa triangle is 10 is if gikan sa ano sa highest point or if ano nimo siya no, if kaning nga orientation padulong sa pababaw is 1/3 siya. Kay dire kay gikan dira padulong dira would be 2/3 of 10. So mahimong moment arm niya is 5 plus kani nga distance which is 1/3 of 10. So 5 plus 10 over 3. So sa area 2 naman, area 2 gikan kani ang centroid sa ano, center lang, rectangle siya. So ang kaning distance would be 5 over 2 lang. So muna siya moment arm. Sa 3, same case lang yapon sa 1. Ang kana nga distance is 1/3 sa 5. So 5 over 3 ang iyahang moment arm. Same sa 4. Gikan dira padung dira 1/3 of 5 gyapon. So nanatay ano no? Kuha na natong individual moment arms. And if yan na nato sa atong calculators, makuha na to ang 4.83 feet. So muna na ato ang final answer. Muna siya ang locations resultant from bottom of wall. That would be all for my report. Thank you.
So hello everyone, my report is all about kinds and design of retaining wall. So first, let us know what is the purpose of retaining wall. A retaining wall is a design to hold in place a mass of earth or the like, such as the edge of a terrace or excavation. The structure is constructed to resist the lateral pressure of soil when there is a desired change in ground elevation that exceeds the angle of repose of the soil. So, iyang purpose kay gina-hold in place niya ang mass of earth o soil. Ang structure sab daw kay gina-resist niya ang lateral pressure of soil. So, kabalo man ta na ang pag-resist niya lateral pressure kay very crucial. Kay ang pressure kay gina-exert niya in horizontal direction. So, important siya because it affects the consolidation behavior and strength sa soil. So, ang retaining wall guys kay ang pinaka main purpose lang gid niya kay gina pa-safe ta para maiwasan jud ang mga landslide og ang kanang mga falling rocks good, like kanang makita gud ninyo sa mga kalsada guys di ba naa may murag pa horizontal dara nga murag bundok. So ginabutangan na siya retaining wall guys kay para if ano kanang mga naaman ko na pisa guys nga kanang nagawik tong spot, so mag landslide jud siya guys. So ang purpose gud sang retaining wall kay para maiwasan to siya og para ma-safe pod ang mga nagaagi nga sakyanan og kita. Example ani guys kay kana makita ninyo sa picture guys, like lang tawa guys, magida-resist niya ang soil niya sa likod para maiwasan ang mga landslide. So move on, let's go to the three types of retaining wall. So daghan jud na siya actually guys, pero mao lang gining pinaka main jud guys nga ginagamit. So first kay gravity retaining wall. So ang gravity retaining wall kay use the gravitational force of their own weight to resist lateral earth pressure from the soil behind them, which prevent toppling and sliding. They are simplest and earliest record type of retaining wall. So mao lang gud gyapon sa kong giingon ganina guys, taga-resist siya lateral pressure kag pero kaning gravitational or gravity retaining wall guys kay mao ni pinaka simple jud nga ginagamit jud. Then second kay ang wait lang. Then ang example na guys kay kana makita nimo sa first picture sa babaw. Then second kay cantilever wall. Cantilever wall are built using reinforced concrete with an L shape or inverted shape foundation. This kind of retaining wall consists of stem and a base slab which sits under the backfill. So kaning cantilever wall guys kay mao ni siya ang naka L shape siya or T shape nga mura niyag stem guys or mura niyag root like tanaw gud mo sa second picture guys ingana yung itsura ang cantilever wall, mura siya na ay root nga gapa L shape ug T shape kay para mas durable ang imuhang retaining wall. Then lastly kay ang reinforced soil wall. Ang reinforced soil wall kay reinforced earth wall are designed as a reinforced soil or mechanical established earth or MSE structure with choice of facing. So ang mga ginagamit ani guys nga mga material kay modular concrete, block, segment panels or full high concrete. Ang example ani guys kay kanang third picture kanang murag rectangular. So move on. Let's go to the design consideration for retaining wall. When designing a retaining wall, there are 7 factors to consider. First kay ang materials. Ang mga materials na dapat gamiton diri guys kay mga durable jud siya guys kay nagaresist ba siya og soil pressure og dapat pag choose sa material i-select jud ang type na the best suited for the required result kanang mga materials nga long lasting jud ba. Then second kay type of wall. The type of wall you choose should be need kanang depende sa place guys. So daghan man types of wall like wall kay kanang mga concrete blocks, stone, brick or gabion. Kanang gabion guys ang na guys kay kanang mura gud siya naa sa screen nga tapos gibutangan og mga dagko nga bato tapos gipatong-patong na siya nga mura gihimo na siya box guys. Then second kay ang then third kay ang design or on-site placement. So planning ahead will help you to avoid the expense and the time it takes to relocate a wall to modify retained areas when they are installed. Then fourth is drainage. So very important jud ang drainage guys kay kapag sa retaining wall mga guys kapag ma-stop mo ang water sa likod ng water kay ay sa likod ng retaining wall kay tapos magdugay ang water dito kung wala kay drainage, so ma-weak tong lupa dito guys, so makakos siya og makasamot siya og cause og landslide. Then fifth kay ang foundation. So important jud ang foundation guys kay dapat durable jud kayo siya. Then ang cant or butter guys kay wall are more stable and structurally secure if they slope back or lay back into retained slope. So important siya guys gyud sa pag-design og retaining wall kay para mas durable ang imuhang retaining wall, dapat nakalibak jud siya sa soil jud. Then last kay anchors or deadman. Ang anchors or deadman guys kay mura na siya og gipasubraan gud niya guys, mura nagkalot sila pasobra dito sa soil og murag T-shape niya pero nasa sa gilid murag ginalak niya guys ba kay para mas durable gid ang imong retaining wall, so important po kay na. So that's all by report, so thank you for watching.
So, ako di ay si Apple May as Buot, and I will be explaining the Rankine's earth pressure theory. So, this is also known as the maximum normal stress theory, and it is developed in 1857 by William John McCorn Rankine. It is a stress field solution that predicts the earth pressures. So, these earth pressure are the active and the passive earth pressure. So, in Rankine, it assumes that the soil is cohesionless or frictionless. So, let's analyze this illustration. So, here is the beta, which is known as the angle of backfill from the horizontal. And this part here is the failure plane or the slip surface or the weak part of soil. And this angle phi is the angle of internal friction, and RA and RP are the earth pressure, which is RA is the active pressure and RP is the passive pressure. And we also should consider the height of the dam or the wall in solving Rankine's earth pressure theory. So, let's proceed. So, in active pressure, we have this formula. The K sub A, which is the coefficient of active earth pressure, is equals to cosine beta times cosine beta minus the square root of cosine squared beta minus cosine squared phi over the cosine beta plus square root of cosine squared beta minus cosine squared phi. And if the beta is equals to 0 degrees and the lambda is 90 degrees. So this lambda here is located here. So if we consider this, or if this is the given from the problem, sa mga problems na ihatag, it is obvious nga ang wall na to is vertical lang, dili siya inani ang forma, which is inclined. So ang formula ani is kini. K sub A is equals to 1 minus sine phi over 1 plus sine phi. And the formula of the active pressure is 1/2 times K sub A times the unit weight of soil and the squared of the height. So this is no groundwater. And if naanay mag-apil na tag groundwater is mauraya pa ng formula, but ang unit weight is malahi na siya. Naapoday tayo lain formula sa coefficient sa active earth pressure, which is equals to tangent squared times 45 minus phi over 2. So, if ang beta is equals to 0 degrees and the lambda is 90 degrees, or in simple words, ang wall niya is vertical. So, let's proceed sa passive pressure. Sa passive pressure is reciprocal lang jud siya sa coefficient sa active pressure, which is ang diriya lang naglahi ang ilahang signs. And here, if ang beta is 0 degrees and the lambda is 90 degrees, mao ni siya ang iyahang formula, which is kabaliktaran lang sa coefficient sa active pressure. Or sa pinakadali pa nga way, ang iyang formula is 1 over Ka. And here, ang formula po dire kabaliktaran ra pod sa active pressure. 45 kung minus to ganiha, plus ni dire, plus 45 degrees over 2. And the formula sa passive pressure kay kini. Same ra gyud siya sa active pressure, but ang nakalahian lang is ang ilahang coefficient. Okay, let's proceed sa example. So, a vertical retaining wall, 6 meter high, with a cohesionless horizontal backfill having a unit weight of 15.5 kN per meter cube, and the backfill has an angle of internal friction of 30 degrees, compute the RA and RP on the wall if it's frictionless. So, let's solve this problem. So, it was stated nga cohesionless horizontal backfill. So, kabalo na ta nga ang iyahang wall is pa-vertical lang. So, mao ni ang national grade line or NGL, and let's write the given. So, unit weight is equals to 15.5 kilonewton per meter cube, and the phi here is 30 degrees. So, since ato ang beta is equals to 0 degrees, and the lambda is 90 degrees, ang ato ang gamiton nga formula is for active pressure. So let's solve for the active pressure first. Active pressure. So ang una to na i-solve is iyahang earth pressure coefficient, which is the K sub A. So ato ang gamiton nga formula dire is 1 minus sine phi over 1 plus sine phi, or tangent squared tangent squared of 45 degrees minus the phi over 2. So, maski asa nga way, same lang gyapon na silag answer. So, let's calculate this by substituting the given values. So, here, one over 3 or 0.333. 0.333. And here, try na to ni. Tangent 45 minus 30 over 2 squared. Yan. Same answer lang sila. So, naanatay coefficient. Next is ang atoan ng RA. So, we all know na ang atoang height is 6 meters. RA, formula of RA is 1/2 times K sub A times the unit weight times the square root of height. So, let's substitute 0.333 times the unit weight na 15.5 times square sa height. So, the answer is equals to, let's calculate, 1/2 times 0.333 times 15.5 times 6 squared. Okay, we have an answer of 92.907 kilonewton. So, nanatay RA. So, let's proceed sa passive pressure. Passive pressure. Okay. So, sa passive pressure is
reciprocal lang siya, 'di ba, sa sa active pressure. So 1 over 0.333, or 'di ba ang Ka ganiha is 1 over 3. So ano lang siya, 3 ang iyang coefficient. Then we can solve the active pressure. RA is equals to 1/2 times coefficient times the unit weight and the square of height. So 1/2 times 3 times 15.5 and the 6 squared. So, this is our P. I'm sorry. So, the value of our passive pressure, or value is 1/2 sa 3 times 15.5 times square sa height, which is 6 squared. So, the value of our passive pressure is 837 kilonewton. Yan. So, here are our answers. So that is all for the Rankine's, or solving Rankine's earth pressure theory. Thank you.
Hello everyone, I am Rimondo, your reporter for columns earth pressure theory. So I am from Group 4 and we're going to be talking about the theory of Charles Agustin de Coulomb. So column earth pressure theory states that the lateral earth pressure is influenced by both the vertical stress of the soil and the angle of internal friction of the soil. So here in Coulomb's earth pressure theory is different surrounding earth pressure theory because Coulomb is considering the friction, internal friction between the soil and the wall. So here is the illustration of our retaining wall and with the soil. So here in the triangular plane, this is what we call the failure wedge. So this failure wedge indicates that this is the one who will gonna give active pressure to the wall. So let's say here, there. And this is our active pressure, which is we're gonna denote it as RA. And this angle, which is perpendicular to the wall angle, that's called as delta. And then the wall angle, let us denote as lambda. And here, the horizontal angle as, and in relationship to the direction of the RA, or the active pressure, that is denoted as theta. And here, this one is our slip surface. Which is the one that is the boundary where the soil will be formed or will be fall, that gives active pressure to the wall. So here in the angle of slip surface, that is denoted as angle alpha. And here, this one is our backfill, so backfill, and that is denoted as angle theta. So I guess that's. And then let us identify the angle here. So it will
minus lambda minus alpha, straight angle. And I guess that's all for the illustration. Here's our retaining wall, our failure wedge, our slip surface, and the angles that are involved in it. So let us proceed to our problem. So here's our problem. A vertical retaining wall 6 meter high with a cohesionless horizontal backfill having a unit weight of 15.5 kilonewton per cubic meter. The backfill has an angle of internal friction of 30 degrees. So compute the following: so the active pressure, the passive pressure, and the angle. So the formula for active pressure is RA is equal to 1/2 of coefficient of active pressure times our unit weight times I squared. And then the question is, what is the formula for coefficient of active pressure? So coefficient of active pressure is equal to sine squared of lambda plus phi. Oh, I forgot who is phi to our illustration. So phi is the internal friction. So that is given as given. Internal friction is 30 degrees. That is the angle of internal friction, where here there is a friction of and perpendicular to the slip surface. This is our angle phi. So going back, sine squared lambda plus phi over sine squared of lambda times sine of lambda minus delta equals 1 plus square root of sine of phi plus delta times sine of phi minus beta over sine of lambda minus delta times sine of lambda plus beta and 1 over squared. So that is our formula of coefficient of active pressure. So let us identify our given the problem. So the problem states that it has a vertical retaining wall. So meaning our lambda or the wall or the angle of the wall is equal to 90 degrees, which is right angle. 6 meter high, which is our height, is equal to 6 meters, with a cohesionless horizontal backfill. So meaning horizontal backfill, our angle beta is equal to 0 because it has a horizontal backfill. It is an inclined, no? So that is equal to 0. So kalimutan take ko natin, no? There is given of coefficient of friction between soil and wall. Coefficient of friction is equal to 0.268. Coefficient of friction is siya between soil and wall. So between soil and wall man, it is denoted as CC is equal to 0.268, and at a unit weight of 15.5 kilonewton per cubic meter. Coefficient of friction na 0.268, meaning coefficient of friction, meaning it is the rise of the rod of our angle. So meaning it is equal to angle delta is 15 degrees. So 15.002, yan na natin siya as approximately 15 degrees. So nanatay angle delta, meaning masolve na natin si coefficient of acting pressure. So ang ato lambda is equal to 90 degrees. Ang ato phi is equal to 30 degrees. Ang ato lambda is equal to 15 degrees. And ang ato beta is equal to 0 degrees. So if you cross out natin siya diha, so ang atong coefficient of active pressure is equal to 0.3014. No? Let us take it in the fourth decimal place. So, masolve na natin ang RA, which is equal to 1 half times the coefficient of active pressure, 0.3014, times the unit weight, which is 15.5 kilonewton per cubic meter, times that sa height squared, which is 6 squared. So we have RA na, so times 0.3014 times 15.5 times 6 squared. Natay 84.091. So actually, the active pressure is force, no? So RA is equal to 84.091 kN. kN siya. Okay, force siya. So this is our answer for active pressure. So sabihin na santa, B, letter B, which is that we will get the passive pressure. So, ang kalahian mo sa passive pressure o active pressure is si active pressure is RP. No? RP. And ang method is coefficient of passive pressure. So, coefficient of passive pressure, ang mag-change lang sa formula sa coefficient of active pressure sa coefficient of passive pressure is ang sign niya, some signs of the formula. So here it will be negative, here it will be positive, here it will be negative, and inside will be all positive. There. So ato ang coefficient of passive pressure, same kung sila yung coefficient of passive pressure is hindi sila same because coefficient of passive pressure is the one that supports the retaining wall. Retaining wall na siya support para isagam niya ang active pressure which is influenced by the soil. So let's erase this one. So here now, here's another one. So let's go from the top. So let's identify our coefficient of our passive pressure. AM. States, bigyan ko sila which is 4 session. Okay. It is our last part in the problem, which is the angle of slip surface. So angle of slip surface, which is denoted as angle alpha, is equal to V plus arctan of negative tan V plus square root, square root of tangent V times tangent V plus tangent V. If times mo siya times 1 plus tangent delta times cotangent V all over 1 plus tangent delta times tangent V plus cotangent V. Angle alpha, and then phi, our angle phi, which is the angle of our internal friction, and internal friction, angle of internal friction is equal to 30 degrees, and our angle delta is equal to 15 degrees. 15 degrees here. 15 degrees. There. So, i-compute natin mo siya. Horizontal backfield and and this is our failure wedge, or failure plane, and this is our angle alpha, which is equal to 56.86 degrees, and wall angle is 90 degrees, which is lambda. And 0 up to angle beta or the backfield because it's horizontal. So, ang delay is angle alpha siya. And then, ang atong angle delta is angle delta here, which is perpendicular to the angle of wall angle. Now, 15 degrees here. Angle delta, and this is our RA, which is equal to ganyan angle basta